Good evening and welcome to your first flipped lesson. I apologize for the tops of these slides getting cut off. There was something with the importing that did change the formatting of the videos, but bear with me and I will make sure that nothing is missed. This is 3.1 and 3.2, functions and relations. Your homework is not this. This is what you're going to do in class tomorrow. Right here. Your homework is to take notes on this lesson, do the examples that I tell you to do, and make sure that you're being careful because those are going to be graded for accuracy, and then submit it into the eBackpack folder. So, this will just be a normal Smartboard lesson with some explanations on the side. So, relations. I realize that we've already talked about this, but a relation is a set of ordered pairs that have some sort of pattern that can be represented with an equation. We'll talk more about what that means in a moment, but really what you need to know is that it's a set of ordered pairs with a pattern. The way that we write sets is with these brackets. That is our symbol for a set. We'll talk more about that when we briefly review domain and range. So there are a few different ways to write out relations. The first is just a normal list of points. The next is a table, which you're used to seeing, all of your x points, all of your y points. The next one is a map, which looks confusing, but it's actually not. So if we look at this map, what we're actually looking at is our domain and range, okay? So we have all of our x values in this oval, and we have all of our y values in this oval. But notice that we don't have any doubles. So even though there are two 2's over here, we only write it the one time. But then we map 2 to its y's. So 2 goes to -10. Just like 2 goes to 10. Okay, by the way, these should have been 25's. 5 goes to -25 and +25, and so forth. The next way you could show a relation is with a graph. Just plot the points. And the final way is with an equation. So this equation is a little bit more complicated than the ones you're going to be seeing now, but what this equation is telling us is that y will be positive or negative 5 times whatever our independent variable is. So if we have 2, we plug 2 in here, so we have 5 times 2, so that means we have either positive 10 or negative 10, which is exactly what you have over here. So you're not going to have to really deal with equations like this in the immediate future, but just keep in mind when you see that plus or minus, that just means that it's going to be the positive or negative version of the answer. So the next thing I wanted to talk about was plotting points. I realized that it might seem a little redundant, but I want to make sure. There was a couple people that had some issues with plotting points on the test, and that's okay. Let's just go ahead and do a little review. Remember that when we're plotting points, we have our ordered pairs, which are in the form x, comma, y. You can remember which one comes first because x comes before y in the alphabet. So anytime you have a point like 5, -6, what you're really doing is going to 5 on the x and -6 on your y, and you can even just draw little lines and find their connecting point. So that would be the point at which 5 in the x meets -6 in the y. Now, if this was called point A or something, I would go ahead and label it by putting an A right there. So hopefully that is clearer. And you can take a look at some more of these points. You can try them on your own if you'd like. There's 5, -6. And the next one will be -5, -6. So I'll go to -5 on the x, -6 on the y. And there we go. And you get the idea. So the next part, we have some questions. Which list of these points are part of the same relation described as y equals 3x. So if I were to look at these answers, I could say, okay, well, there is -1, -3 is one ordered pair. This is my x, this is my y. So I'm going to plug -1 in for my x and see what I get. I get -3, because 3 times -1, because that's what I plugged in for x, is equal to -3. So that point checks out. Now let's try the next point, 0, -2. So I'll go ahead and say 3 times 0, that's equal to 0, which would be my y. That is not the case here, therefore that can't be a possible answer. And I'll go through and do that with all of these points and see which one works out, and you'll find that the correct answer is D. And I could go ahead and do the exact same thing for the next question, which list of points are part of the same relation as x plus 1. So in this case, I can, again, start the same way. So I could say, okay, if x is -2, then I have -2 plus 1, which is -1. So that works. And then I'll have, try this point, I'll have 0 plus 1, that equals 1, so that works. And I would find out that 2, 3 works and 4, 5 works as well. So my answer is A. For these next three, you get to do them on your own. So these will be the first 3 examples in your notes. So you'll have question 3, question 4, and question 5. So here's question 3. Go ahead and pause it and give it a shot. And here you have question 4. And after you are done with question 4, you have question 5. So those should be the first 3 examples in your notes. So, just as a reminder, there are lots of ways to label your parts. You know you have x, y, which is the same as your input and your output, as well as your independent and dependent variable. Hopefully that is all review. Alrighty, so in this one, I have a couple questions. In this relation, what is the output when the input is 1? So I'll look, and I'll say, okay, well, when my input is 1, my output is 0. So let's go ahead and see if that's right by plugging 0 in. And sure enough, it's right. And the next one, it says, what about when y equals -2? So you can see, I look for where y equals -2, and that is when x is -1, and that is correct. In this next example, we have a map. So we have our relation mapped here, and you need to figure out the answer to the next 2 questions, which will be your next example. Similarly, on the next page, you can pretty much make out those points. You've got -5, -1, -3, 0, -1, 3, 0, 4, and 2, 5. Answer the next 2 questions, and that will be your 5th example. And you guessed it, this is your 6th example. So now let's talk about functions, one of the most important parts of algebra. So functions are special types of relations, but keep in mind that every equation is a relation, because a relation is really just showing us a set of points that can be symbolized with an equation. The next thing we need to know is that only some relations are functions. So think of this like rectangles and squares. All squares are rectangles, but not all rectangles are squares. Similarly, all functions are relations, but not all relations are functions. The key definition for a function is right here. There is every one input has exactly one output. Okay? And when you have a graph, you need to use the vertical line test, which is a very simple, easy way to see if a graph is a function. And we'll go over this and this in just a moment in more detail. All right, so if we take a look at these graphs, we have several different types of graphs here. We have a regular parabola, and we have a couple others. So a vertical line test is when you take an actual vertical line, take a pencil, piece of paper, whatever, and you're going to take it all the way across the graph. If that vertical line ever hits more than one point at a time, it's not a function. So this one only hits 1 point at a time, so it's a function. But this one obviously has 2 points that hit the same vertical line, right? So the way you can think about it is if you can see that, that's 5, right? So here is the number 5 on the x-axis. And this point right here is approximately, I'd say 1.5 on the y. And then this point's probably approximately about negative 1.5 on the y as well. Well, that's one input. And here I have 1.5 and I have negative 1.5. Those are two different y's or two different outputs. Therefore, it is not a function. The vertical line test shows me that because look, we have this vertical line and it hits 2 points at a time. Therefore, it fails the vertical line test and is not a function. So if you take a look at the next two, you'll notice that we have a circle which fails the vertical line test, therefore it's not a function. And we have a regular line which passes the vertical line test because it only hits 1 point at a time, meaning there's only one output for every one input. So take a moment to look at these different graphs and decide whether or not they're functions or non-functions. And we'll see if you are correct. So that is not a function. That is not a function because neither passed the vertical line test. That passes. That passes. That does not pass. That one passes. That one passes. And that one does not pass. And so we have divvied up our functions and non-functions. So I'd like to take a moment to talk about domain and range just because there were some issues on the test. Remember that this is not showing me domain and range. That's showing me an XY table. If I asked you for the domain, you'd say D colon or domain colon, a bracket because it's a set of numbers, and then you'll list in numerical order all of the X values. Remember not to list doubles. So if there was 2 2s, you would only need to write one of them to indicate that that is part of the domain. Here we're being asked for range, which is listed just like domain. So we'll list them in numerical order, not listing doubles, making sure we have nice brackets, and that is how we list our range. Again, this is not how you show domain and range. That's how you show your X and Y table. List your domain and range as a set of numbers. So I wanted to touch upon some vocabulary. A function is a relationship that assigns exactly one output value for each input value. I don't really care for the definitions here, so the domain is the set of all X values. The range is the set of, you guessed it, Y values. So just to be totally clear, if we look over here, we can see the domain for this function. We can also see the range. Notice how they are listed numerically. I would like you to complete the last portion, this side portion over here, on your own, as I believe the 6th or 7th example. And the last couple of items we have to talk about is the set. A set is a group of stuff, said in the probably worst way I can think of, but a set is really just a group of stuff. It really is. It's just a list of random things. This is actually the next thing as a little bit of a test to see if you actually viewed the video. So keep that in mind when you see the next picture, which set my couple of my 8th grade girls into hysterical laughter. This is an example of a very bizarre set. Not really sure what's going on there, but it is a set of stuff, so it does fall into the definition. And yeah, when I ask tomorrow what that secret random thing is, that's it. So you can prove that you watched the video if you feel so inclined. So a relation we already talked about, and an element is just a part of a set. So here we have domain and range. This is a function because you have exactly one input assigned to exactly one output. So 1 can go with 5, 2 with 6, 3 with 7, 4 with 8, etc. This next example is also a function because when you look at it, we have all of these points. Now I'm going to pause this for a second and point out that anytime you have a list of x values and none of them are repeating, it's a good sign you're probably dealing with a function, especially if you don't have any repeats with your y's. But if we take a look at this example, this is not a function. Take a minute to think about why before I tell you. So let's go ahead and figure it out. If we're looking at the domains here and we're looking at the ranges here, the first thing I notice is that there's only 4 numbers in the domain and there's 5 in the range, which tells me that at least one of these numbers is a double. So let's say hypothetically 5 was a double. So really we have 2 5s that must correspond with 2 different numbers in the range. And we know that because we know that our domain and our range, actually, we don't list our doubles. And since we only have 4 in the domain and we have 5 in the range, that means that we have at least 5 points. Therefore, one of these must repeat. And one of those, whichever one is being repeated, must correspond with a different number than the other of the repeat. In other words, you probably have something like 8 12 and also 8 7. Well, that is the same input with 2 different outputs, which is not 1, which means it is not a function. So here's another example of a non-function. I'm going to go ahead and list each point. So far, so good, but here we have another 15 and a 19. That means it is not a function because there are 2 the same input with different outputs. So if I were to graph that, if here's 15 and here's 19 and here's 24, what's going to happen is you're going to have something that looks like this. You're going to have your point 15, 19, and you're also going to have your point 15, 24. But notice that that is a vertical line, right? That's a vertical line, which means that we have 2 points that are hitting the vertical line, so it does not pass the vertical line test. All right, so this last slide is probably one of the most important slides of the lesson. I know I've told you guys about asking questions, and if you don't ask a question, about something you don't understand, then it might catch up to you. Well, f of x was something I didn't understand when I was in algebra for a long time, and it wasn't until a couple years later when I did the research and I started asking teachers that I actually realized what it is, and it's actually super easy. So the function of x is written like this. Let me write that a little bit neater here. So that is, you can say that either the function of x or the way that I will probably most often refer to it, which is f of x. What that's telling me is a function of x is equal to some equation. But guess what? F of x is exactly the same as y. It's just a more accurate way to talk about y. So if we look at this equation here, it says f of x equals 3x minus 5, that is identical to this equation. Because f of x and y are the same thing. F of x is actually probably a more accurate way to describe what you're finding, because what you're saying here is that you've got an output, which is your function. Your function of x is what creates your output. Whatever x is going to create the output, right? So when we're talking about this, you're just saying what happens when I plug x in to an equation, I get this output, which is a function. So what exactly does that mean? All right, so I've got this equation. F of x equals 3x minus 5, and they're asking me to solve for f of 5. And you're probably thinking, wow, what? But it's actually a lot easier than it looks. We know that this is what the function of x is. So now they're asking, what is the function of 5? Well, we can solve that quite easily by saying, okay, well, I know that I've got 3x minus 5 is my function of x, but now I know that x is equal to 5, because that's what it tells me, because this is x here, and this is the x we're looking for. So I just plug 5 in for x into the equation and I solve it. So I'll find that I'll get 15 minus 5, which is 10, which means the function of 5 is 10. So you can find the function of an infinite amount of numbers just by plugging it into x, because that will give you the function of whatever number you plug in. Here are the final two examples for the lesson. You've got b of x and g of x, and you need to solve them both. Don't be alarmed that it's a different letter. It's just the same thing as a function. They're just trying to confuse you. So you'll have g of x and b of x. You can complete these the exact same way I just completed the last problem. So that is the end of the lesson. Please complete these and your notes and take a picture with Scanner Pro and submit to the eBackpack folder. Thanks, guys.